All right, good morning, folks. This is Mike coming back at you with yet another video on Foundations of Math 2. In this video, we are continuing to talk about statistics, and we are going to look at measures of position. Measures of position help us to figure out where a particular value of data falls compared to the entire set. We sometimes use measures of position to report scores, like say testing scores. This is commonly done with tests like the SAT or the GRE. The GRE is like the SAT, but for going into a graduate program. And the number that you get, or the score that you get, is called the percentile or the percentile rank. Yes, for the SAT, they do give you an actual score of, say, 1,200 or 1,140, but they also give you a number out of 100, and that number out of 100 is your percentile or your percentile rank. The percentile of a particular data value is simply the percent of the data values in the entire set that are below that particular value. So what I mean is, say you took the GRE and you got your results back, and you see the number of 82. Well, that 82 doesn't mean that you scored or got 82% of the points on the test. It doesn't mean that you got 82% of the questions right. It just means that you scored better than 82% of all the people who took that same test on the same day at the same time. You could have actually gotten only, say, 40% of all the problems right, and you could have actually only gotten 40% of all of the points, but if everybody else did not as good or worse, then your percentile is going to be higher. If you got 82nd, or if you ranked in the 82nd percentile and you only got 40% of the points, then that means that 82% of the people who took the test did worse than a raw score, if you will, of 40%. So that's how percentile works. It's you compared to everyone else, not you versus the number of points or the number of questions right, or you versus a fixed scale. It can also work in the opposite way. You could have been given, say, and everybody else then could have been given, say, a really, really simple test, but say you had a couple small miscalculations, and say your raw score, say you got 92% of the questions right, or you got 92% of the points, but because of those few small miscalculations, it's possible that you could have a percentile score of, say, 55, because you only scored better than 55% of the people who had taken that test. The other 45 or so percent scored better than you. So tests being scored on a percentile rank, it's kind of tricky. Once again, it's you compared to how everyone else did, not how you did compared to the fixed scale of points and questions right. So getting into some sample problems now. Suppose the test scores of 12 students which includes your score of 71, are listed below. What percentile is your test score? So we see we have our 12 test scores right here. And what I would recommend you do in this case, just like we did with finding the mean, the median, the mid-range, and the mode, I would suggest taking your data and putting it in specifically increasing order, so that you can see, okay, how many pieces of data are truly less than yours, and that kind of thing there. So if I put this data in increasing order, my lowest grade is a 40 here. Then going up next, I see a 59. Anything less than a 59? No. 61, is that the next lowest? Yep. 66, no, we have a 64. Now we have our 66. Notice that we have two 70s. Then I have a 71. I have an 80, and an 87, a 92, and a 95. So we have our 12 test scores, but now they are in increasing order. We said that the percentile or the percentile rank is the percentage of the data values in the set that are below the particular value. So how many test scores do we have less than our test score of 71? Well, there's 1, 2, 3, 4, 5, 6, 7 values that are less than our score of 71. And how many test scores were there total? 12. So 7 over 12, if you plug it into your calculator, as a decimal, is equal to 0.583, and that 3 repeats. But you see the word percentile, we have a slightly shorter word in there, which is percent. So we're going to write this as a percentage. So converting from decimal form to percentage form, this is 58.3 repeated percent. Now, typically, percentile scores, we don't typically go to anything beyond the decimal. So it's more likely that you would see this written as your test score is in the 58th percentile. But if you want to be really specific with it, it's 58.3333333 3%. So 58th percentile. And again, this means that you scored better than 58's, technically 58.33333% of all the people who had taken the test. So this is one more case where your raw test score is actually higher than the percentile that you got. But notice what we did to figure out this percentile. We took the number of data values that were less than ours, we divided it by the total number of values, and then to get it as a percentage, we really just multiplied by 100. That's what we did, or that's what you do when you move the decimal place to the right 2 spots. You're just multiplying this thing by 100. And that's our general formula To find the percentile or percentile rank of a particular data value x within a data set of n values. The percentile of your value x is simply the number of data values less than x divided by n, and then that quotient times 100. So doing a couple more samples here. Suppose you graduate 32nd in a class of 220. What is your graduation percentile or your graduation percentile rank? Your percentile is going to be, well, the number of data values less than you. In this case, that's the number of people who graduated after you. So how many people graduated after you when you graduated 32nd in a class of 220? Well, it's going to be 220 minus 32 divided by the total number of data values, aka the total number of people. And then that times 100. And if you do a little bit of mental math, or if you pull out your calculator, if you do 220 minus 32, you get 188 divided by 220 times 100. And once again, for the sake of just writing this out, I'm just going to round to the nearest whole value here. So that's going to give us 85%. Technically, it was 85.45, and that pattern of 4, 5 is repeating. But again, technically, you're going to typically see these things as whole numbers, not as a decimal part showing up after it. So in this case, we would say that you graduated in the 85th percentile. Now, sometimes, maybe you've been part of this, maybe you haven't. Maybe you have a friend and you went to the same high school or the same college, and you graduated in separate years, and obviously based on the year you have varying sizes of the class that graduates, and maybe you have a little competition going of some sort just to see who graduated higher in their class. And just going off of the number place in which you graduate doesn't necessarily mean that you graduated at a higher rank. And this next problem here showcases that exact case. John graduated 51st in a class of 1600, and Jane graduated 27th in a class of 570. Which student had the higher percentile? Now, just going off of the numbers, we would think, okay, Jane graduated higher because she graduated 27th, John graduated 51st. But Jane's class had a significantly smaller number of people than John's did. So let's see what this does. Let's see who has the higher percentile. So I'm going to say the percentile for John, and I'll write it P sub John, is going to be the number of people who graduated after him, which is going to be the 1600 minus the 51, divided by the total number of people, 1600, times 100. And if you do this calculation, and we plug these numbers into our calculator, the actual value we're going to get is 96.8125%. So we'd say approximately the 97th percentile, or 97%. Percentile for Jane is going to be the 570 minus the 27. That's the number of people who graduated after her, divided by 570, and then that times 100. 570 minus 27 divided by 570 times 100. And if you do that calculation, you get approximately 95.26%. Again, this would probably be represented by the 95th percentile. So, after calculating the percentiles, which student had the higher percentile? It was actually John. John had the higher percentile rank. So John could make a valid argument and would probably win the argument that he graduated higher in his class than Jane did in hers. So these are the kinds of things that you just kind of have to watch out for. Just going off of the place in which they graduated, yes, that's important, but that doesn't paint the entire picture. You also have to look at how many students were in their graduating class. Okay, so we know how to find percentiles. That's good. But if we're given an overall set of data, perhaps not too many points or too many values for the purposes of what we are going to do, we want to get a sense of the data and where most things fall, but without being too detailed and too super nitpicky about all the finer aspects of it. And we're going to do that with the type of plot that we are going to stumble on very quickly here. So going back a couple of videos, we talked about how the median divides a data set into two halves. Half the data is less than the median, half the data is greater than the median. But now that we know percentiles and this stuff, we're also interested in the quartiles. And these are the values that will divide the data set into quarters. So in your overall set of data, again, typically we'd have this ordered from smallest value to greatest value. We have the smallest value. On one end, we have the highest value or the greatest value on the other. We said we have the median, which essentially splits that entire set of data in half. But now we have these quartiles, the first quartile and the third quartile. The first quartile is simply the value that is a quarter of the way into the set of data that we have. And the third quartile is simply the data value that is 3/4 of the way into the data that we have. Another way to put it, the first quartile is the value that has a percentile rank of 25. 25% of the data is less than the first quartile. The median has a percentile rank of 50. 50% of the data is less than the median. And the third quartile has a percentile rank of 75. So 75% of the data is less than whatever this number that is our third quartile. Now, finding the median we know how to do. Finding the first and third quartiles is very straightforward and not that complicated at all. It's very much like finding the median of a slightly smaller set of data. To find the first quartile, which you often see symbolized as Q1, you're just finding the median of the values that are less than the median of the whole set. So you have the median for the whole set here, which is our second quartile. A second quartile, as maybe you can guess, is sometimes symbolized by Q2. So you take all the data less than your second quartile or your median, and you find the median of that set of data. Whatever that median is, that is your first quartile Q1. To find the third quartile, often symbolized by Q3, we're going to find the median of the data values that are greater than the median of the whole data set. So again, you take your median, there's 50% of the data values that are greater than whatever this number is, find the median of that data set, and whatever that median is, that is your third quartile Q3. And we have something called the interquartile range. We're going to come back to this at the end of this video, and we're going to see where we use that. But the interquartile range is simply the distance between the third and the first quartiles. It's the simple, straightforward calculation of Q3 minus Q1. All right, so we are going to stop here for now. In our next video, we are going to continue on with this, talking about percentiles and all that good stuff. And we'll get into drawing box plots or box and whisker plots. If you have any questions or comments, please be sure to reach out to me, guys. Texts, emails, voicemails, pigeons, or letters sent by carrier pigeon. You can send actual pigeons with notes inscribed on them somehow. Whatever you feel you have to do. Until the next video, take it easy, guys.